Okay, so this is Edexcel Core Pure 1, June 2019 again. It's question 2 this time. And we have a little show that. It's integral, we've got an infinity as one of our limits here. So we're going to have to be thinking about, right, what does the integral tend to? So that's going to be quite interesting. Interesting little thing to integrate here, looking like partial fractions. 2x squared plus 3 does not factorise, obviously, so we're going to have some nice partial fractions to do here, and it's to show that we need to show that it's equal to ln k, where k is to be found. So let's start off by doing our partial fractions. We can see here this isn't improper or anything, we just got 8x minus 2 on the top, so we're going to split this using our partial fractions into ax plus b over the quadratic 2x squared plus 3. So that's your standard form for quadratic factor on the bottom, on the denominator. And then we got c over x plus 1. So multiply those over, and now we're at 8x minus 12 is identical to ax plus b times x plus 1 plus c times, oops, that's a bit small c, 2x squared plus 3. With the cancelling that goes on when you get to there. Now, looking at this, obvious pick first of all, let's make x equal to minus 1 to make this 0, so we can forget all this, we arrive straight at c. So, we let x equal minus 1, over here we're going to get minus 20. Over here, 0 there, minus 1 in here, we're going to get minus 1 squared is 1 times 2, 2, 3, 5c. And so therefore we arrive at c equals minus 4. Yes, nice start. Okay, now we've got to look for finding the other values. So again, if we're going to pick some values, x being 0 would be a nice one, that will get rid of the a. We can ignore that. And we already know what c is, so if we let x equal 0, well, that will be minus 12 there, equals, that's just going to be 0 times 1, 0 plus 1, 1, times the b, because that's going to be 0, so that's just b there. Yeah, all falls out nicely. And over here, we know x is 0, so it's 3c. I'll put 3c, but we know c is minus 4, so putting that in there, oh, look at this. We end up with b is 0. Interesting. Okay, right. And then finally, we just got to find the a. Now, there's numerous ways we can do this. So let's go down coefficient comparing. So let's compare coefficients of x squared. Don't have to, just show that there's lots of different ways we can arrive at this. So, coefficients of x squared. On this left-hand side, nothing. We got no x squareds at all. Over here, though, we can see if we multiply this out, we get an ax squared. And we get 2c's in terms of our x squared. So when we multiply these out, that's the number of x squareds, our coefficient of x squared that we would get. We know c is minus 4, so we're going to get a minus 2, 8 there. And so therefore a equals 8. Lovely. Okay. So we've done the first bit, which is our coefficients, done our partial fractions, and we're arriving at that. I'm going to make my life a little bit easier by just putting those numbers in there. So b is 0, a is 8, let's put 8 in there, and c is minus 4. Now, I know you wouldn't do this, but minus 4 up there, so that was a plus, so let's make that minus 4 over x plus 1. Make our life a little bit easier. Okay, so here we go. We're now going to do some integrating. So we're now going to integrate between infinity and 0. This is now turning into this. 8x over 2x squared plus 3 minus 4 over x plus 1. All right. Now then, we're interested in what's this situation here where we've got infinity as the upper limit on this. So our process is we go, right, we're going to turn this into a t. And what we're going to be interested in is the limit as t tends to infinity. So instead of putting infinity in, which is obviously a daft thing to do, we'll put this letter t in and then say what happens to our answer as t gets closer and closer, well, goes towards infinity, tends to infinity. So let's turn it into that. Set it up nicely. Now comes our integrating. So we got little clues as to what we should be aiming for here. We're showing that it's ln k, and you can see that these two are lovely integrals that will turn into lns. So limit as t tends to infinity of. Now let's deal with this first one here. The differential on the bottom of the denominator has to equal our numerator to be a straight ln here, but it's not quite. When we do differentiate 2x squared plus 3, we get 4x. We haven't got 4x up there, we've got 8x, we've got twice as much. So actually, when we integrate this, it's going to be 2 ln of 2x squared plus 3. Okay? So you really just got to say, right, okay, I can see that when I differentiate 2x squared plus 3, I get 4x. I've got 8x, that's twice as much. If you like, some people like to kind of think of it as, oh, I'm going to rewrite it as 4x. Now it's perfect. And put a 2 at the front, because the 2 times 4x makes the 8x. Kind of, it's just to show that, I know that that is a perfect ln 2x squared plus 3. And now I've got to do 2 times it. But I don't think that's necessary. I think you can see the kind of factor you have to do in terms of multiplying here. Same here. Obviously, the denominator, when you differentiate that, you get 1. We got 4 up the top. That's 4 times as many. So it's simply minus 4 ln x plus 1. And this is between t and 0. So let's do a little bit of tidying up, shall we, here? If we tidy this particular bit up here, we would get limit t tends to infinity. Now, we're subtracting 2 ln terms, and those 2 ln terms have got a 2 and a 4 there. So, there's a couple of things we could really do here. We could bring the 2's up and the 4 up as powers. And then because we're subtracting, divide. So if we're feeling really nice and brave here, we could go straight to 2x squared plus 3 squared over x plus 1 to the power of 4. So we dealt with the minus ln 2 terms, means we're dividing. Obviously we need to put the powers up first before we do our dividing, but I've done that in one clean swoop. And we are now at that situation, t and 0 there. Right, I'm going to give myself a bit of space up here, do a little bit of working. So, if we put the t in, obviously we're just going to get that. We're going to get ln, so this is the limit, as t tends to infinity, of ln of 2t squared plus 3 over t plus 1 to the power of 4. Minus putting 0 in. Now don't forget about putting a 0 in, because you never know, there's something that could arrive from that. Well, if I put 0 in here, I'm going to get ln of 0 in there, it's just giving me 3 squared, so 9 at the top. Putting 0 in there, I'm going to get 1 to the power of 4, so 1. That looks pretty nice. Okay, so we got, putting the 0 in there, getting 1 to the power of 4 is 1. Putting 0 in there, obviously 3 squared, giving us 9. Now then, we're going to have to consider this situation now, and what happens as t tends to infinity. So, if we think about it, Oh, I'm missing a squared there, dearie me, come on, Bren. That's it. If we think about it, ln 2t squared plus 3 squared over t plus 1 to the 4, if we sort out those powers and expand it out, now this one we could probably do just writing down. 2t squared plus 3 times 2t squared plus 3 is going to give us 4t to the power 4 plus 12t squared plus 9 all over, and then t plus 1 to the 4, we do a little binomial expansion, we're going to get t to the 4 plus 4t cubed plus 6t squared plus 4t plus 1. Now you might, if your binomial expansion isn't quite up to speed yet, you might have to do that to the side and kind of do your t plus 1 to the power 4 bit of a binomial expansion to work out what that is. In the end though, really it doesn't matter too much, because as t tends to infinity, the t to the 4 term dominates. You know, even though we've got t cubes here and t squared, as t tends to infinity, all these lower powers of t become insignificant compared to the huge size of t to the 4. So actually, as t tends to infinity, of this, oops, write it all out. Ugh. All these terms become nothing. That is the only thing that matters, the 4t to the 4 over the t to the 4. And obviously that cancels to 4. So that actually becomes ln 4. Yeah? T to the 4's cancel, so you're left with 4. Everything else becomes completely insignificant as t goes to infinity. The t to the 4 dominates. So we are left we are left with that this whole integral here becomes equal to ln 4 minus ln 9. And that is obviously ln 4 over 9. So there's our k equals 4/9. So it's really just understanding that as t tends to infinity, the lower powers become insignificant. We just concentrate on the higher powers, and oh, here we go, a little bit of dividing. We're going to get 4. Okay? Marvellous.